Hello everyone and welcome you to our channel Schrodinger's Cat, and this is basically Devabrata here. In our previous lecture we had discussed the laws of motion from class 11, and in today's class we would basically discuss the from class 11 topic, and today we just discuss here the magnetism from class 12. So today we will cover the moving charge and magnetism, Biot-Savart law and Ampere Circuital law, magnetic force on charged particle in magnetic field and motion in magnetic field, torque and force on current carrying conductor, moving coil galvanometer, second on magnetism and matter, bar magnet and magnetic dipole moment, magnetic dipole in uniform magnetic field, Gauss law and magnetism, magnetic material and its properties. And basically the number of questions are coming in NEET exam. There are 2 or 3 questions are coming, and JEE main 3 or 4, and the JEE advanced 3 questions are coming. So this is the important topics. So let's get started. So first of all, that the magnetism and the magnetic dipole moment. So I just draw a line here for you to clarify. So first of all is that the moving charges and magnetic field, basically the Lorentz force. So the Lorentz force is defined as, and one thing I just saying that for your exam point of view, today we will discuss the chapter summary in a nutshell, and after that we just broadly elaborate the theory, and today chapter summary and problem discussion coming in recent question NEET, JEE main and advanced. So Lorentz force is defined as the F is equal to Q V cross V. So basically this would be the Q VB sin theta, and if F is 0 or 180 degree, for theta 0 degree or 180 degree, the F would be 0 minimum, and for theta 90 degree, the F would be QVB. So second one, motion of charged particle in a magnetic field where the V is perpendicular to B. So this is the F QVB is equal to mv square by r. So radius of the path would be r equal to mv by qb, and the time period t would be 2 pi r. Basically the s t equal to s by v, s 2 pi r by v, and the frequency is 1 by t is written as the qb divided by 2 pi m. And next, that the while entering in charged particle making angle theta with magnetic field B, the resulting path would be a helix, and this radius of the circular path would become in this form of defined as the r mv sin theta divided by qb, and the time period t would be 2 pi m by qb, and the pitch p is t into component of v along the axis x v cos theta, that would become 2 pi m v cos theta divided by qb. So next one, that motion of charged particle in combined electric and magnetic field. So here third case, 3 case. First one, B is parallel to E and initial speed is 0, Q charge and the mass m. Here acceleration QE by m, and the equation of motion y half at square QE by m into t square. And another one is v square equal to u square plus 2s, u means 0 square plus 2, a means qe by m into y. So q ey is equal to half mv square. Another two is that initial velocity u, and for initial velocity u, that u equal to u and all remains same. So here acceleration qe by m, and the y ut plus, here initial speed u, so ut plus half at square, that the qe by mt square, and v square is equal to u square plus 2a qe by m into y, and the qey, the equation of motion written here, the half mv square minus initial speed half mu square. Third one, that the speed would be 0. So this is most important, and here y equal to half qe by mt square, x, here this is basically in the form, this is a circular path and the point y here, so this direction is x and this is the y, so this point is z, so this is the r and the making angle theta with the origin, and this tangent velocity v. So x equal to r sin omega t, r sin theta, theta means the omega t, and the z is r minus r cos omega t, and here r is mv by qb and the omega is qb by m, and velocity vector of the particle here v is v naught cos omega t I plus qe by m p z direction plus v naught sin omega t k. So next, force on a current carrying conductor placed in a magnetic field is F is I L cross B, I L cross B is written as, I means current here, IBL sin theta. For theta 0 or 180 degree, the F would minimum, and for theta 90 degree, the F would be IBL. Go ahead our next, that is the moment of couple on a carrying rectangular loop. So the moment here, the tau, the tau is n I a b sin theta. Here AB basically the length. Sorry, just think that here the torque tau is Ni AB sin theta. Here A means area of the loop. Here basically the A is L into B, and B is the magnetic field. NIAB sin theta, A is L cross B, area of loop, B is magnetic field, and I is current. So magnetic dipole moment. Next, the magnetic dipole moment is written mu or M is equal to IA. So M for n terms, NIA. Torque on loop tau, basically the M cross B, written as the MB sin theta. Next one, the work done in rotating a magnetic field is W work done is equal to MB 1 minus cos theta. Potential energy of a dipole placed in a magnetic angle theta is minus MB cos theta. Minus MB cos theta. And work done for angle theta 1 to theta 2, that W is equal to MB cos theta 1 minus for theta 2 cos theta 2. Basically the W is U2 minus U1. Next one is that gyrometric ratio, that the mu by L is Q by 2m, and this is the constant, where mu is the magnetic dipole moment and L, here L be the angular momentum. L be the angular momentum. So go at our next topic, that the magnetic field. So for the magnetic field, first one is the Biot-Savart law. So magnetic field due to a current carrying conductor is dB proportional to I, proportional to dl, proportional to sin theta, is proportional to 1 by r square, is written as dB is equal to constant mu naught by 4 pi I dl sin theta by r square, where mu naught is 4 pi into 10 to the power minus 7 Newton per ampere square. Next, magnetic field due to a current in a state where, so this is written as, for a state where B equal to mu naught by 4 pi I by A sin phi 1 plus sin phi 2. Phi is the angle between the center of the line and the point we have to find the magnetic field. Same as B is equal to mu naught by 4 pi I by A cos theta 1 plus cos theta 2. So in general case, if phi 1 is phi 2 equal to 90 degree, and here one thing is that theta not equal to phi, and theta 1 is equal to theta 2 is equal to 0 degree, we have the magnetic field mu naught by twice pi I by A. Next one, force between two parallel current carrying conductors is written as F by L equal to mu naught by twice pi I1 I2 by R Newton per meter. Magnetic field at the center of circular current carrying coil. For circular coil of n turns is written as the magnetic field B equal to mu naught n I divided by 2R. Magnetic field due to a circular arc, this is important. This is a arc, current I, and here the magnetic field B, the angle theta, this is R. For circular arc, mu naught I by twice R theta by 360. Next one is that field at an axial point due to a circular loop. For circular loop, this is a circular loop, the field at that point, this is the A and the R. We have to find this point and this is current I. For circular loop, the magnetic field would become mu naught I A square divided by 2 A square plus D square to the power 3 by 2. If D greater than A, D much greater than A, that B would become the mu naught by 4 pi twice mu by D cube. Second one is the Ampere law. This tells us the closed line integral of B dot dl, line integral, is equal to mu naught into I. Magnetic field inside a long current carrying solenoid, this is equal to B mu naught Ni, where N is N by L. Number of turns per unit length, this is for the solenoid, SOLE, NOID. Next one is for the toroid. The magnetic field would become mu naught N I by 2 pi r for the toroid. So next one, field due to a infinite current carrying hollow cylinder. For infinite current carrying hollow cylinder, B would become 0 when R less than capital R and mu naught by 2 pi I by R when R greater than equal to capital R, where R cylinder radius become R and R means the find out magnetic field, and the graph would become this type of graph. This is the R and here this point is capital R and here the R. B versus graph for infinite current carrying conductor. So next one is that field due to infinite current carrying solid cylinder. For solid cylinder, B would become that mu naught by 2 pi I R by R square, where R less than R, and for mu naught by 2 pi I by R for R greater than equal to R. And this graph would was important, I think on times is coming in NEET exam or JEE main. This is the capital R, this is the R, here this is B, this is B proportional to R and here proportional to 1 by R square, sorry 1 by R. Next one is that field due to an infinite cylinder with internal and external radius. Suppose a cylinder with internal radius R1 and external radius R2, this type of cylinder, we have to find the field, the outer internal radius R2 outer radius and the internal radius R1. This would become the magnetic field is written as 0 for 0 less than equal to R less than equal to R1 and mu naught by 2 pi I by R that r square minus r1 square by r2 square minus r1 square for r1 less than equal to r less than equal to r2, and for mu naught by twice pi I by r for r greater than equal to r2. So next one is magnet, permanent magnet. So we just go ahead the discussions here. For the permanent magnet, magnetic charge M placed in a magnetic field B, so experiences a force F is equal to mb, and B is written as mu naught by 4 pi m by r square, and the magnetic moment of a bar magnet M 2ml, magnetic charge into distance. And I just suggest one thing is that you just compare yourself for studying first the electrostatics, magnetostatics, and as well as the gravitation, because in gravitation F equal to G m1 m2 by r square, F equal to G m1 m2 by r square. For electrostatics 1 by 4 pi epsilon naught q1 q2 by r square. For magnetostatics mu naught by 4 pi m1 m2 by r square. You just compare and study these three at a glance. Now, for the torque on a bar magnet placed in a magnetic field, define as the tau is equal to m cross b, and at an angle theta, the potential energy would be minus mb cos theta. So minus m dot b, potential energy minus m dot b, and this formula is very important. Expression for time period, omega is equal to root over mb by I. This is most important case, mb by I, and the time period is 2 pi by omega. Just put this value 2 pi root over I by mb. Fourth one, that magnetic field due to a bar magnet. So magnetic field due to a bar magnet as per the electrostatics, first one is the end on position. End on position. So for the end on position, B would become mu naught by 4 pi, the constant, 2m by r cube. This is in Newton per ampere meter. And for broad on position, this would become B equal to mu naught by 4 pi m by r cube. Next one is that magnetic scalar potential. Magnetic scalar potential is V2 minus V1. The potential difference is integration R1 to R2 B dot dr as per the electrostatics. And for a pole of pole strength M, UR would become mu naught by 4 pi m by r as per the electrostatics potential energy. Here is the magnetic scalar potential. Magnetic scalar potential between a or because a magnetic dipole. For magnetic dipole, the scalar potential Vp would become mu naught by 4 pi m cos theta divided by r square. This is Sn of magnet, this is angle theta and the r. Next one, horizontal component of the Earth's magnetic field. Horizontal component of Earth's magnetic field. So this is the BV and here this is the B, this is the BH, BV, BH, and this is the B, and the angle is delta. So tan delta, tangent of the delta is equal to B vertical by B horizontal. So B would become, is resultant B vertical square, B horizontal square, and delta is 0 degree of equator and in pole is 90 degree. Go ahead, our next topic, that the tangent galvanometer. So for a tangent galvanometer, this is the tangent galvanometer, that I current would become 2R BH by mu 0 n tan theta. Basically the I equal to K tan theta. This relation is important. I equal to K tan theta. Reduction factor of the galvanometer, K be the reduction factor of the galvanometer, is equal to 2R BH by mu 0 n. Moving coil galvanometer. First one is tangent, next one is moving coil galvanometer. So for the moving coil galvanometer, that I equal to K by NAB theta. So I is proportional to theta, and K by NAB, this is galvanometer constant. This part is galvanometer constant. So next one is the shunt. So just draw this diagram here. This is the galvanometer and this is the reaction of I. Here current is divided into two parts. This is resistance of shunt R. Here current I2, here the current I1. This is current the I. So here the I1, the potential divider rule, R plus R into I. Gauss law for magnetism. So it says that as per the electrostatics, line integral of, basically the surface integral, you said that basically the ds, integration of B dot ds in a closed loop is equal to mu naught m. M is the pole strength, m inside, you just write m inside, and this term B dot ds is called the magnetic flux, and m inside is the pole strength. So next one, I just compare one thing for your better understandings of electrostatics and magnetostatics in the last one. And here we just now discuss the magnetic property of matter. In my last topics we just cover the basic difference of two, and here we now cover the magnetic properties of the matter. So for the magnetic property of matter, intensity of magnetization I, is equal to m by v, where m be the magnetic moment, v be the volume. this is equal to M is 2 ml and V is the A into 2L. So it would become M by A. Magnetic intensity H. So magnetic intensity H is B by mu naught minus I. If I is 0, so I is 0 means no material in present, so H would become B by mu naught. You are aware of this relation, but this is main fundamental. When I is 0, this will come. Magnetic susceptibility is defined as the I equal to chi H. Chi be the susceptibility of the material. This is the susceptibility, SUSCP, susceptibility of the material. Next one, the permeability is equal to mu naught 1 plus chi, and the relative permeability mu r is written as mu by mu naught is equal to 1 plus chi. For paramagnetic system, the mu r is greater than 1. For the diamagnetic, mu r is less than 1, and for ferromagnetic, mu r is the order of 1000. Next one is the Curie's law, chi equal to C by T, and basically written as C dashed by T minus Tc. So Tc is called the Curie's temperature and T greater than Tc, and Tc is called the Curie's point. So next one is that paramagnetic, diamagnetic and the ferromagnetic comparison. That I just write one thing is there, and another is that for para and dia and the ferro, for para chi is positive and dia chi is negative and ferro chi is positive. Mu r, here mu r is greater than 1, I just write here, and here mu r is less than 1 and mu r order of 1000. This is the main difference. Last one is the transformers. This is important for your NEET exam. One question is coming in these topics. N1 turns of primary coil, N2 be the secondary coil, and the epsilon 1 be the EMF of the primary coil and epsilon 2 be the EMF of the secondary coil. I just not write here the figure. You just think, and the relation is epsilon 2 is minus N2 by N1 epsilon 1, and the power transfer, for the power transfer means for our commercial case, for our use, epsilon 1 I1 is epsilon 2 I2, so I2 basically the minus N1 by N2 into I1. And one thing is that transformer is step up and step down two case, and here the efficiency of the transformer is output power P output by P input. So our main fundamental case is that the comparison of electrostatics and the magnetostatics. So basically for doing this, here we just compare, just a minute, we just compare here the two systems. Basically for your better understanding, we just draw a line So these are our electrostatics. We just study in your previous lecture. Now this is the magnetostatics. Magnetostatics. So first one, here is charge and here is pole strength, and here the force is 1 by 4 pi epsilon naught q1 q2 divided by r square, and here the f is already just a vector, you just know, mu naught by 4 pi m1 m2 by r square. Just compare this. Here the electric field E, that is equal to F by Q naught, and here the magnetic field B is F by M naught. And here also the Gauss law is applied here. Next one, the field due to a dipole. So for a axial line, here the electric field, that for the axial line 1 by 4 pi epsilon 2p by d cube, and here this would be the B for axial A. BA would become mu naught by 4 pi 2m by d cube. For equatorial line, that here 1 by 4 pi epsilon naught p by d cube, and here m by d cube. B equatorial mu naught by 4 pi m by d cube. Main formula is that E equal to 1 by 4 pi epsilon naught p by d square plus L square to the power 3 by 2. This is case p by d cube is case for L less than d, and here n greater d, and here the main is the B equal to mu naught by 4 pi m by d square plus L square to the power 3 by 2. This is for case m by d cube L less than d, and here L greater than d. Next one, field at any point. This is very important. Field, and suppose this is a charge of plus q and the minus q. We have to find field at this point. Here this field direction is the direction, and here the d, and this is the angle alpha. So here we just write the electric field at the point P 1 by 4 pi epsilon naught p by d cube root over 1 plus 3 cos square theta. And here the same case, this is the north pole here, and this is the south pole of the bar magnet. This is a point and this angle is theta. This is the magnetic field direction B, angle B the alpha, the distance is d. So here one thing is that very important, that tangent of the alpha angle is equal to tan theta by 2. And another thing is the magnetic field, that the mu naught by 4 pi m by d cube root over 1 plus 3 cos square theta. So we just compare by the mathematical formulation of the electrostatics and magnetostatics. Now we just go ahead our problem discussion session. First one is coming in NEET 2021. A thick current carrying cable of radius r carries current I uniformly distributed across this cross section. The variation of magnetic field, what would be the better? So for current carrying tether, for the inside we just know, for the inside the magnetic field, that the mu naught I divided by 2 pi r square, we just come to know from our previous chapter summary in a nutshell. So proportional to r, and for the B or the outside that the mu naught I by 2 pi r. So this is proportional to 1 by r. So proportional to r is this one, as proportional to 1 by r is this one. So you just come to know for the play with the graph section for the JEE main and advanced mathematics skill. So our C would be our correct answer. This would become the proportional to r and this is the 1 by r. Go ahead, our next problem coming in NEET 2024. So I just saying one thing that for your NEET exam they are coming the match type of question, that saying match list 1 with list 2. NEET 2024 recent question: diamagnetic, ferromagnetic, paramagnetic, non-magnetic, chi equal to 0, this. So for diamagnetic substances or materials, the chi range is 0, greater than chi, greater than equal to -1. For the ferromagnetic, chi much greater than 1. For the paramagnetic, 0 less than chi less than 1. Or you just for non-magnetic substance, that chi is 0. So match this. A would be your correct answer. A2. So diamagnetic, this relation. For ferromagnetic, greater than 1. So B would become 3. And next one for the paramagnetic. So paramagnetic substance, this is for small positive number, this one, and you just write this one, the epsilon, the small positive number, some number, 1 or more, 2, this one. For non-magnetic it would become 0. For non-magnetic would become 0. So go ahead, our next JEE main 2021. This is also recent questions. A hairpin like shape as shown in the figure. You have to find the magnetic field. So two stateware and half semicircle. This is stateware and the half semicircle. So for stateware, I think this is 1, this is 1, this is 2 semicircle and 3 is stateware. So for state there here that the B1 is equal to B3. Stateware magnetic field is mu naught I by 4 pi r, and the semicircular B2 that mu naught I by 4 r. So neat magnetic field is equal to B1 plus B2 plus B3, that would become mu naught I by 4 pi r plus mu naught I divided by 4 r plus mu naught I by 4 pi r. Just calculate, just common here, mu naught I by 4 pi r, and you would become 2 plus pi. So I think B would be the correct answers. Mu naught I by 4 pi r, 2 plus I. Next, JEE Advanced 2022. Which one of the following represent the magnetic field of this figure in XY plane? Just stateware, half semicircle, another half semicircle, this stateware. So, and I think this is a stateware. This is a stateware. Suppose I give 1, here this is 3, and this is be the quarter. For I just 2. Quarter means 1/4. Semicircular, and this is the quarter. So 1, 2, 3. These two stateware. This is quarter means circular. You just, this one is given. So quarter number 2, B2. So net magnetic field, and the difference between the JEE advanced, here you have to find the direction, this direction you have to find magnetic field direction. So B neat is equal to B circular plus B quarter plus B state wire, so equal to that mu naught I divided by 4R, R means L by 2, and the direction minus K cap. For direction you just F equal to Q V cross B, and here V is not given, L is given, so you just for direction you just apply here the F is I dl cross B. F is given and dl length is given and the B magnetic field, and the Ij, this is the I, J and the K, and I cross J is equal to K. You just come to know this point, we have already discussed in the vector chapter. And second one is mu naught I divided by 8R for quarter, so 8 would come 1/4 into 2, 8. This is L by 4 and direction minus K cap. Next one is the mu naught I by 4 pi R for state where you just know 4 pi R means L 1 by root 2. This is R and direction minus K. So 4R, R means L by 2, and for quarter 8 and 4 pi R. You just solve. So mu naught I by 2L plus mu naught I by 2L plus mu naught I, this would become 4 root 2 pi L, and the direction be the minus K. So after solving you just get mu naught I by L 1 plus 1 by 4 root 2 pi, direction minus K cap. So I think C would be our correct answers. B equal to minus this minus which come first, minus mu naught I by L 1 plus 1 by 4 root 2 pi K cap. C would be our correct answer. Go ahead our next topic, next problem, final problem, NEET 2017. An arrangement of 3 parallel straight wire placed perpendicular to plane of paper carrying same current I along the same directions as shown in the figure. You have to find the magnetic field. Magnetic force per unit length or magnetic field is what? So you have to find the magnetic force F. Magnitude of force per unit length or the middle of the wire. So this is a straight wire and the force would become, I just show here, this would be the F resultant. So one thing that F resultant is equal to root over 1 by F1 square plus 1 by F2 square. So F1 means, and here F1 is, F2 is F, so this on the F and this is the F. Got it? So F here you just know for straight wire F that mu naught I square by 2 pi R, here R means D. So F R, that F1 square plus F2 square the resultant. So F1 F2 is F, same force, angle theta, so root 2 F. Just put this value root 2 F means mu naught I square 2 pi R. 2 pi R means D. So in NEET exam, one thing is keep in mind for physics, NEET exam short type of question, short calculation is coming. For JEE main, short calculation is 2 or 3 line for NEET, and JEE main 4 or 5, and JEE advanced 7 to 9 calculation. Just keep in mind for your exam purposes, mu naught So this is for in general case, but all of questions is not done with 7 or 9 lines for the JEE main and advances. So this would become the mu naught I square divided by root 2 pi d. So D would be our correct answer, mu naught I square by root 2 pi d. So we just complete 5 important and fundamentals question for JEE main, NEET and advance, and I think you solve all the questions after solving our 5 practice session. So here for your better understanding and conceptual thinking and practice, I just usually give you for your homework 5 another questions in NEET, JEE main and advance. You just take a screenshot pausing this video. I just wait 8 or 9 seconds. So I think you just take a screenshot of these problems. So basically we have done the 10 important question in magnetostatics or magnetism chapter, and I think you just have a knowledge of this video and chapter summary in a nutshell and problem discussion session. So last but not the least, that if you need this material file of my YouTube lecture, just mail without no hesitation catschrodingers1935@gmail.com. So last but not the least, thank you very much for the audiences. Stay well and happy. Have a good day. Thank you.